If this is your first video on the channel and you are completely new to programming, I suggest that you start at the beginning of the series. The playlist to the series will be linked in the description of the video and also in the YouTube cards in the top right corner. In the last video, we talked about arithmetic and assignment operators, and what I planned for this video at first was to continue explaining the operators and cover comparison and logical operators. But then I thought the best way to explain those operators would be by using if statement. So here we are. In this video, I'll explain if statement, and then in the next video, we'll cover comparison and logical operators. With that out of the way, let's dive directly into the code. When you're making a game of any genre, whether it is a racing game, an adventure game, or whatever crazy concoction of ideas in your head you're making that game out of, one thing is certain, and that is you, as the god of creation, will have to make arbitrary or logical decisions which will decide how your game world will function. For example, let's go back to the RPG analogy and think about the loot system in your game. Now, for a while, think that the game world is sentient and has its own thoughts. So, watching your battle with the enemy while reclining with a bowl of popcorn and a bottle of Coke, the game world is thinking, if the player surmounts this battle, then I'll give him 1,000,000 gold coins and some rare herbs, and maybe even the huge axe that his enemy is wielding. Here, the game world is creating is what we call a conditional or a decision-making statement. It has created an if statement with the condition that will decide what will happen after the battle ends, and the condition is based on whether the player wins the battle or loses the battle. If the player defeats the enemy, the game world will magically drop some loot as a reward for winning the battle, but if the player loses, nothing will happen. Now, let's come back to reality, where the game world is not sentient, and you, the god of creation, will have to decide and write this arbitrary or logical concrete condition which will decide when the loot will drop. So to start off, let's declare a boolean named _has player1, which will be true if the player wins the battle and false if the player loses the battle. Now in the start method, let's write a conditional that will let our game world know what to do when the player wins the battle. To do that, we have to type if bracket _has player1 is true, closing bracket, debug.log player has won the battle, and the game world will reward him with X amount of loot. Semicolon. That's it. Now let's break down this block of code just to make sure that you understand how this works. First is if and the two parentheses, which will tell your compiler that you are writing an if statement. Then comes the condition between the two parentheses, that is _has player1 is true. If this condition is met, then everything between these curly braces will be executed. And if this condition is not met, then everything between them will be ignored by the compiler. Pretty simple, isn't it? Now let's go to Unity and check the logs. As you can see, it says player has won the battle and the game world will reward him with X amount of loot. Back to the code, let's go and change _has player1 to false and look at the logs again in Unity. As you can see, nothing was logged, as that's the whole point. Because the condition of the if statement was not met, the compiler ignored what was written inside the curly braces and skipped ahead. In the last Unity log, nothing was printed in the console because the condition was not met. But let's say, instead of not printing anything, we want to log a default statement inside the Unity console if the condition was not met. The if-else variant can be used to do just that by adding the else block right after the if statement like this. Else debug.log player lost the battle, semicolon. Here, if _has player1 is true, then it will print the log inside the if block otherwise it will print the log inside the else block. Just remember that if the condition that governs the if block is not met, then the debug.log inside the else block will be printed every single time, as there is no condition attached to the else block. For example, let's say that this piece of code was executed while the player was still battling the enemy, and the battle's outcome has yet to be determined. Even if that was the case, because the condition for the if statement, that is _has player 1 is true, was not met, the log inside the else part will be printed, and you will see player lost the battle printed inside the Unity console. This is also why I said the else block is used to write default statements that will be executed only if no other condition before it has been met. Usually, how I write conditional is by making it so that I will only enter the else block if something went wrong in my logic. But I'm getting ahead of myself. For now, let's go to Unity and check the logs. As you can see, it says player lost the battle. This means that our if-else block is working as expected. Going back to the code, now let's say you don't want to print the debug.log inside the else block every single time that the condition for the if statement was not met, and only want to print it if the player has actually lost the battle, which is how it should be. This is where the third variant, that is the if-else-if-else block, comes into play. If we take the existing code and turn else into else if like this by adding a condition, and then after the closing curly braces of else if, create an else block like this and log something went wrong inside of it, then now we have created an if-else-if-else variant of the if statement. You can stack as many else ifs as you want after the first if statement. There is no limit to it that I know of. Adding the else block is also optional, and you can just use if and else ifs with no generalized else block. Now let's go to Unity and execute this piece of code. As you can see, it says player lost the battle, but this time this log was printed not because it is the default log for the else block, but because it is the log for else if block that would only be printed if the player has actually lost the battle, and would not be printed if the player is still battling the enemy. Back to the code, now comes the last variant, which is called nested if. But before going into the code, let's continue with the previous example. We only want the code we wrote to be executed if the player is battling the enemy or the outcome of the battle has been decided. And we don't want this block of code to be executed if the enemy doesn't exist and the player was just having a dream. So to get something like this accomplished, we will declare another boolean named _enemy truly exists and set it to false. Then we will take the code that we have already written and put it inside a new if block like this. And in between the parentheses as the condition, we will type _enemy truly exists is true. And then, just for fun, let's add an else block and log player is having a dream inside it. And that's it. You take an if statement of any variant and put it inside another if statement, and bam, you have a nested if statement. Now, as we have set _enemy truly exists to false, when we go into Unity, we should get a log saying player is having a dream. So let's go to Unity and check the logs. And as we expected, the idiot was just having a dream. One last thing I want to cover is in what precedence you should write these conditions. So the condition that you put at the top of the block should be the most important condition in your conditional block. because the compiler will evaluate the conditions from top to bottom, while the succeeding conditions should be in the decreasing order of importance, with the last condition or the else block having the least importance, being executed only if nothing above it has met the conditions defined. Taking the example of the player dreaming about the enemy, the most important condition is whether the enemy truly exists or not. Only if the enemy exists do we move ahead and think about whether the player won the battle or lost the battle. If we wrote a code where the evaluation of player winning or losing is done before we check whether the player was dreaming, at best, we would just lose some processing power because the code block, which otherwise did not need to be executed, is being executed now, while at worst, we will have an insufferably buggy game that not even you, the developer, will wanna play. Well, that does it for today's video. If you like the content, I hope that you will subscribe to the channel. I would love to hear your thoughts in the comment section, and as always, if you see someone struggling down in the comment section, do try and help them. Goodbye for now, this is your host VP signing off.